Hello students, welcome you all to another video of our channel. So today we will discuss about diffraction. In previous video we discussed about all type of interference, then how interference occurs in double slit experiment, how interference takes place in thin film and its application to Newton's rings. Now we are going to discuss about diffraction. So the term diffraction, what is diffraction? How diffraction occurs, what are the different types of diffraction and single slit diffraction, as well as we will discuss about diffraction grating in this video. So first we will discuss about what is diffraction. Already you know that when ray of light travels from one medium to another medium, it bends. And is known as refraction, and the cause of refraction is change in speed of light. When light travels from one medium to another medium, it bends. Similarly, diffraction is also the phenomenon of bending of light. Now we may get confused. Refraction is bending, again diffraction is bending. Let me clear that. Refraction is, again I am repeating, refraction is when ray of light traveling from one medium to another medium. Then it bends, and the cause of refraction is change in speed of light while traveling from one medium to another medium. But diffraction is when ray of light travels in a medium and strikes any obstacle. If any obstacle is there in the path of light, then it slightly bends. That phenomenon is said to be diffraction. In case of refraction, there is two different medium. For example, light travels from air to water or water to air, so it slightly bends. But in diffraction, if light is traveling and one obstacle is present on its path, then it strikes and slightly bends. That bending phenomenon is said to be diffraction. The best example in day-to-day life of diffraction is skylight. You must have seen sunlight traveling through the skylight. Skylight, let some diagram or some holes are there. But while light travels through the skylight, on the other side you can see the beam of light slightly widen away. So the widening of the bending of light after striking the skylight and spreading is known as diffraction. I hope diffraction is clear. Let's go to the definition. So definition you can see here. Definition is written, diffraction is nothing but the phenomenon of bending of light around the corner of an obstacle. When an obstacle is present, in case of false ceiling also you can see, if ceiling is there, light strikes, then slightly it bends. That phenomenon is said to be diffraction and spreading into its geometrical shadow. So here is an example. You can see ray of lights are traveling here. Due to presence of the obstacle, a part of light is spreading or bending. That phenomenon is said to be diffraction. Now we are going to discuss about what are the different types of diffraction. Always remember, diffraction is of two different types. One is Fresnel's diffraction, another one is Fraunhofer diffraction. Then what is the difference between them? In Fresnel's, when the source from which light is coming and the screen on which diffraction pattern we are observing, both are present close to the obstacle. That type of diffraction is said to be Fresnel's. In Fraunhofer, the complete opposite one, when the source and screen are present far away. So two different types of diffraction, one is Fresnel, one is Fraunhofer. So in Fresnel's case, both the source and the screen are present close to the obstacle. They are present close to the obstacle. But in Fraunhofer, both are present at a larger distance or far distance from the obstacle. Since the source and screen both are present close to the obstacle, if source is there and light is traveling, and here is the obstacle, and here is a screen on which we are observing the bending of light due to obstacle. Since both are present close, we don't need any lens to focus. But if the source is present as a far away and the screen is present as a far away, in order to focus the light, we need a lens. For example, sunlight. In order to focus the sunlight, we need a magnifying glass. You must have done that experiment in school. Magnifying glass, if you focus, if we put a paper, then you can see after some time the paper will start burning because of the focus. Light focus on the paper. So intensity of light increases and it starts burning the paper. So when ray of light travels from a larger distance Then in order to focus, we need some lens, that converging lens. So here in Fraunhofer case, magnifying glass or converging lens are used. Converging lens are used in order to focus the light. Clear? Next we will go to single slit diffraction. What is a single slit diffraction? We will discuss now. In Young's double slit, we discuss about interference, where two slits are there. For that reason, that is said to be double slit. Here we consider a single slit. Let a single slit is there. Now we are going to find out how rays of light are diffracted due to presence of this slit and what is the pattern. Here the intensity graph is drawn. I will explain you about how intensity varies and the diffraction patterns are also given. That means here also we are getting dark and bright alternate fringes, but there is a difference. You can see the widths. I will explain each one of them, how the intensity varies, what is the principle behind this change in fringe width. I will explain. So let's go to the derivation part. Here let a source S is there and a slit is present whose width is, let A. A is width of the slit present. Now one screen is present here. Any name you can give, XY screen is present. When ray of light starts falling here, they will travel in a parallel way, because here you can see straight line path. But due to presence of this slit, they will start bending at the center. This is the center. Let we are giving name A. This is B. This is the center point O. And a part of light will start bending. If we consider a point P here, ray of light will also bend from here. Clear? Similarly, on the other side also, you must have taken some point here also. Ray of light slightly spreads towards this point. From here also you can draw. Clear? On both sides you can take. We are taking only one side now. Okay. Let this bending. Let this bending is angle is theta. So path difference. What is path difference now? Path difference is the difference in the distance traveled by both the rays. Ray of light travels from A to point P. Ray of light travels from B to point P. So there is a difference in path. From the figure you can see the when ray of light starts traveling from B to P, it will travel more distance as compared to the fast light A to P. So in order to calculate path difference, if we plot a perpendicular here, if we draw a perpendicular, let B to N. This distance we already know, this is A, this width A. So BN, B to N will be A sine theta. Here you can see this is 90 degree, this is hypotenuse, so sine theta, this is theta. The sine theta is always equal to P by H. So P equal to H sine theta. In this triangle H is A to B, so A, B sine theta, and AB is we have taken A sine theta. For that reason I have directly written the path difference B to N is A. So this is B to N, perpendicular is B to N, B to N. So B to N is the path difference between light traveling from A to P and B to P. Clear up to this? Now we are going to use the conditions for constructive as well as conditions for destructive. So let's go to the next page. So we get path difference Bn, path difference is A sine theta, and we have fringe width, like we have the slit as A, B, and the difference is here A. Let we divide this into two equal parts. We have divided this into two equal parts. See, we consider the path difference as lambda. This is completely imaginary. We imagine the P point is situated in such a way that the path difference is lambda. That means A sine theta A sin theta equal to lambda. We assume that let path difference is lambda. So if we divide equally A and B, we divided from the midpoint. So AC and AB. For each point, the path difference between A and B, we consider A and B path difference, we consider lambda. Since C is the midpoint, the path difference between A and C will be lambda by 2. Similarly, C and B will be lambda by 2. I am giving you one easy example. For example, A point, B point, A 1, 2, 3, 4 and 5. Let these are the numbers. So the difference between A and B is 4. Clear? Midpoint is here 3. This is the midpoint. So the difference between A and C, this is 2. This difference is just 2. Same thing here. Since we consider the total difference, path difference as lambda, this half distance will be lambda by 2. This half distance will be lambda by 2. Then for every point in the upper half, in A and C, there must be a corresponding point in lower half, that is CB, where path difference will be lambda by 2. That means if the difference between A and C, B and C we consider, both the differences are 2. A and C difference is 2, B and C difference is 2. Then there must be a point 1.5. Then corresponding point will be there 3.5, where difference is 2. 2 corresponding point is 4, so difference is 2. Then 2.5 corresponding point will be there 4.5, difference is 2. So for every point in the upper half, there must be a point in the lower half where path difference is half of that. That means lambda by 2. That means when one ray of light travels from here, another ray of light travels from here, and they interfere, their interference path difference is lambda by 2. So path difference is lambda by 2 means that is destructive interference, because from interference we know that the conditions are for constructive interference path difference is always even multiple of lambda by 2, and for dark points or destructive interference path difference must be odd multiple of lambda by 2. So whenever light travels from upper half and light travels from lower half and they interfere, then there will be a path difference of lambda by 2, and that is nothing but the condition for destructive. That means whatever assumption we have taken, we assume that A sin theta equal to lambda, that is the condition for destructive interference. Very important. This is the condition for destructive interference. Destructive interference. A sin theta equal to lambda, or you can write down A sin theta equal to 2n into lambda by 2. Similarly, this is in general case, okay? Lambda, 2 lambda, 3 lambda, or sin theta equal to, we can directly write 2n into lambda by 2a or n lambda by a. For small angle, you can directly write down theta equal to n lambda by a. This is the condition for destructive interference. Destructive interference condition is this one. Clear? Same thing here also. We consider let one point A, another point B, and the width of the slit is A. Now let the path difference A sin theta is 3 by 2 lambda. 3 by 2, 1.5 times of lambda. Now if we divide that slit into 3 equal parts, that this is C, this is D, then the difference between A and C will be lambda by 2. Similarly, C and D will be lambda by 2. This distance is also lambda by 2. Equally, we divided the entire slit into 3 equal parts. This is one part, this is another, this is another. Total path difference we assume 3 by 2 lambda. So each half will be lambda by 2. Now, when light travels from first part and second part, there will be destructive interference. Already we have discussed. because for each point in the upper half there must be a point in the lower half where path difference will be lambda by 2, and that is the condition for destructive. Now for each point in the upper half there must be a point in the lower half where path difference will be lambda. You can see this is lambda by 2, this is lambda by 2, so the total path difference will be here lambda. If path difference between them is lambda, that means they interfere constructively. So whatever condition we assume here, again I am giving you the same example in terms of number. If A, so that it will be more clear for you. If 1, 2, 3, 4, 5, 6 and 7, then we divide it into 3 equal parts. Clear? So if we divide it into 3 equal parts, 3, then 5 and last one is 7. Here the difference is 2, here the difference is 2, here the difference is 2. Then if 2 is equal to lambda by 2, as we consider as lambda by 2, let this is also lambda by 2, this is also lambda by 2. Then for every point in the upper half there must be a lower half where the path difference is lambda. We consider that is at the destructive interference. But for first and third, path difference is lambda by 2 plus lambda by 2, that is equal to lambda. This is the condition we consider here. So this is the condition for constructive interference. So whatever we consider here, A sin theta equal to 3 by 2 lambda, that is the condition for constructive in case of single slit diffraction. Similarly, it will be A sin theta, then 5 by 2 lambda. If we take, in general, you can take A sin theta equal to 2n plus 1 odd by 2 into lambda, or sin theta equal to 2n plus 1 by 2 lambda and A. For small angle, you can write theta equal to 2n plus 1 into lambda by 2a. This is the condition for theta. So here we will get the positions of dark points. Clear? This is the position. Here we will get the position of bright points. So the condition for dark points in single slit is theta equal to odd multiple of lambda by a. Now you get the condition for the constructive interference. So here you can see the condition for constructive interference is odd multiple of lambda by 2a, and the condition for destructive interference is even multiple of lambda by 2a. Now we are going to discuss about the intensity part. So here you can see the intensity in diffraction varies completely different as compared to that of the interference one. In interference, intensity of all the points, all the bright points remains constant. But here intensity of central maxima means the diagram we did here. You can see O point is equal distance from A as well as B. So path difference between light traveling from A to O and B to O is same. Since path difference is same, this point path is same, so path difference will be 0. If path difference 0, O point will be maximum point or bright point. So we are telling that point or saying that as the central maximum. So intensity of central maxima is always maximum here. Then this is secondary maxima. As we move on both sides, you can see there is a decrease in intensity. And here if we intensity of central maxima is 1, then the secondary maxima is 1 by 22, then 1 by 61, 1 by 121 and so on. Intensity gradually decreases. Then what are the points? What are these points? These are the dark points. These are the dark points, right? So then in terms of theta we can also write. Here we get the condition for dark points. If you put n equal to 1, n equal to here 1, 2, 3 and so on. If you put n equal to 1, then first angle will be lambda by a. Destructive for destructive we get condition theta equal to n lambda by a. where n equal to 1, 2, 3 and so on. N is not 0. If n is 0, that is central maxima. If you put n equal to 1, then this is lambda by a, then 2 lambda by a and so on. Similarly here minus lambda by a, minus 2 lambda by a and so on. Now we are going to calculate the angular width. Angular width of the central maxima. Angular width from theta to this is minus lambda by a, from 0 to this side, this is lambda by a. So total angular width will be 2 lambda by a. If from the central maxima to the first minima is 30 degree on right side, 30 degree on left side, so total angle will be 60 degree. This is here, and negative sign just indicates that on the left hand side. This is angular width. Linear width. Then what is the linear width of central maxima? So linear width, you must have remembered the formula, theta equal to arc length by radius formula. So arc length equal to theta into radius. We are going to use this formula. So here the linear width is theta means this angle, 2 lambda by a, and radius. What is the radius here? Now radius here is nothing but the distance of the screen. The distance of the screen from the slit. If it is at a distance capital D, then we are going to consider capital D as the radius formula here. So if capital D is distance, then this is 2 lambda capital D by small d. This is the central maxima linear width. You must have seen there is a difference in Young's double slit experiment. We get the fringe width beta equal to lambda capital D by small d, because we use small d as the distance of separation between the two slits. Here we use a as the distance of separation of the slit or width of the slit. So we get 2 lambda capital D by small d. So this is nothing but 2 times of beta. So the width of central maxima is 2 times as the width of interference patterns get in Young's double slit experiment. Now we are going to calculate the width of secondary maxima. What is this width? Width of secondary maxima, you can see the angle difference will be here lambda by a, distance is d. This is lambda by a, this is 2 lambda by a. So difference is lambda by a, distance, this is equal to beta. So the width of central maxima is 2 times the width of secondary maxima, and secondary maxima width is same as the fringe width in Young's double slit experiment. Clear my point? And intensity of central maxima is maximum, and as we move on right side or left side, you can see there is a decrease in intensity. Then how the intensity decreases? In the ratio of 1 by 22, 1 by 61, 1 by 121 and so on. Gradually the intensity varies. I hope this is clear. If you have any question, you can let me know in the comment section so that I will clear. Then we have the difference between diffraction and interference. So diffraction is bending of light around the corner of any obstacle, and interference means superposition of light. In diffraction we get intensity maximum for central maxima and gradually decreases on both sides. But in interference, intensity of all the bright points remains same. In diffraction, the fringe width of central maxima is 2 times as that of secondary maxima. But in interference, in Young's double slit, we must have seen that derivation also. The fringe width is constant throughout the fringes. And one more important thing, since intensity gradually decreases in diffraction, the contrast of fringes is not good, poor contrast. But in interference, since intensity of all the points are same, so the contrast is very good in case of interference. So these are the difference between diffraction and interference. You can see secondary maxima are decreasing intensity here, but here intensity remains same. Here central maxima is double the width of secondary maxima. Here all are of same width. Then superposition of waves takes place taken from the same wavefront, because single slit here takes that from the two coherent sources. What do you mean by coherent? Let me know in the comment section. Then contrast is not good, contrast is good. This is all about difference between diffraction and interference. Next we are going to discuss about diffraction grating. Here see, plane diffraction grating. Grating means when large number of opaque lines are drawn on a transparent medium. For example, if any glass is there and large number of opaque lines are drawn here. Yeah. So when light travels through it, the light only will travel through the space between these points. So we are getting the diffraction pattern. Generally, diamond cutters are used in order to create these opaque lines over a glass, and there are 10,000 to 15,000 lines present in a grating. And the sum, for example, if we plot a grating, so when source is there, light will travel in all possible direction. Light will travel, and in other side we can see the bending of light. If width of each slit is E, width of each slit width is E, and the distance of separation between two slits is D, then E plus D is said to be the grating element. E is here the slit width, and D is here the distance of separation between two consecutive slits. Then E plus D is said to be grating element. Clear? We don't have any derivation here. We have to just use that missing order spectra as well as some applications. So missing order spectra, you can see the principal maxima of grating spectrum are obtained at E plus D sin theta equal to N lambda. This is the general formula. We use D sin theta or A sin theta equal to N lambda. Here in place of A we have E plus D, where E plus D is said to be the grating element. Again, for dark points or minima, we know that E sin theta. Already we have studied for single slit. E sin theta equal to M lambda. I have just changed the notation because it will make confusion. What is N, what is M? N and M are two different numbers. N starts from here maximum and M stands here for minimum order. Now missing order means when completely darkness will be there. So if we divide these two equations, then E plus D divided by E equal to N by M. So this is the condition we get. If N and M satisfies this condition, then this order of light or this order of diffraction will be completely vanished or completely dark. This is said to be missing order spectra. You must have seen in the practical, you must have observing in practical that we have central maxima, then completely darkness, then first order, again completely darkness, then second order central maxima. So in between some orders are completely missing, that is said to be the missing order spectra. This is because of this condition. And if E equal to D, then N equal to 2M, 2 times the double. Next we can easily calculate the wavelength also, because we have E plus D sin theta equal to N lambda, and E plus D if we calculate N lambda by sin theta, the grating element. Similarly, if we rearrange, we can easily calculate lambda also. Another one is dispersive power of a grating. So dispersive power formula is d theta by d lambda. If we take derivative of this line, this will be E plus D sin theta will be cos theta, and d theta by d lambda, which is equal to, on the right side we will have N, and d theta by d lambda we have to divide N divided by E plus D and cos theta. This is the formula for dispersive power of a grating. Clear? Now you have two numericals here. Do both the numericals. Let me know the answer in the comment section. In the next video we will meet. We will discuss about the electromagnetic theory part. Okay. So do these numericals and let me know in the comment section. And if you have any doubts or any questions, you can let me know in the comment section so that I will clear that in the next video. Thank you.